This
Mary,
conference will now be recorded.
You can go ahead and ask me. I'll cut it off.
just wondering what time we should wrap up. Like how much time is?
Oh,
How
yeah,
long is this?
if you can wrap about 15 to 10 minutes before the hour,
Okay,
that would give us time to have at least a few questions. We can run over, but a lot of people drop off at the top of the hour.
sounds good. Thank you.
Okay, I think I'll go ahead and start the webinar. I see Emily's joining us here now too. At any rate, good morning, good afternoon, good evening, as the case may be. I'm going to kick off this webinar. Before I start, I just would ask you to please mute yourself. And if you have questions as we go along, maybe type them in the chat. And we should have time at the end that you could also unmute yourself and ask Sam your question directly. So I wanted to kick this off and give a little background or context and then introduce Sam. As most of you know, there's getting to be more and more data products out there, water quality products. There are constantly new ones being generated all the time. And we had a thought, you know, as part of, say, this water quality information service, whatever that may be, you know, how can we pull together all these different disparate data sets, you know, be it satellite remote sensing generated data or in situ data. And at that time, I had a conversation with Sam Batzli, and we talked about this RealEarth portal, which has the capability to do just that, you know, bring these different data sets together, be it data sets with different data structure, temporal, spatial resolutions, coordinate systems, things like that. So we talked about it and drafted a proposal for some internal money, which was funded. And today, Sam's going to talk about this fun project that we've been involved with. As part of the introduction, Dr. Sam Batzli is a data engineer with training in historical and cultural geography at UW-Madison Space Science and Engineering Center. He develops access to satellite observations of not just water, but land and atmospheric and oceans through GIS and internet mapping. He consults on data interoperability and visualization for colleagues through NOAA, NSF, and NASA funded projects, and a broad public user community through the America View education outreach program. So with that, I'm going to turn it over to Sam.
Thank you, Steve. Yeah, I feel grateful to have the opportunity to present some of the work that we've been doing with regard to global water quality. And so I think I'll just get right into it with a brief slideshow here to get started. So sharing my slides, which you should be able to see now. Let me know if you can't, I'll just assume you can. So, so the idea here is visualizing and integrating global water quality observations with embedded RealEarth web maps. So I'll first talk a little bit about what RealEarth is. It's a visualization platform that we developed at the Space Science and Engineering Center and the Cooperative Institute for Meteorological Satellite Studies, which are units of the University of Wisconsin-Madison. And the idea is that we're providing satellite imagery and related data products with the concept of it being near real time and also globally of the Earth. So that Real Earth comes from that concept. It's built on open source software, including these various programs and libraries. The purpose is to provide a simple interface for data visualization and comparison across different disciplines and domains, so atmospheric, oceanic, and earth science. And that's a challenge, but we do it by orienting by time and location. and we allow visualization through different kinds of Earth observations in a single interface. And we take it even further by creating a possibility of archiving particular incidents and of particular time and place. But generally, the focus is on near real time. The last thing is we allow the customization of the interface, which we'll be looking at later. So the general architecture for this is we have a collection of servers on premises at UW-Madison that comprise a whole sort of federation of virtual machines. So we might have multiple virtual machines on a particular server, but we end up with, I think we have 18 individual servers and about 32 different virtual machines right now. And the data flows in through the internet and also through our direct reception facility on the roof of our building at UW-Madison. So you're seeing that with the data inputs. I don't know if you can see my cursor, but here in the upper right corner, the inputs, we get data from all over the place. We go out and harvest particular static data sets and put those in, but we also have cron jobs running constantly that are importing data as it's received. Some of it comes in every minute if it's the case of a GOES mesosector, or it comes in every year if it's like a land cover data set. So we have kind of a huge range of time. And we have spatial resolutions that go down to centimeter level, as well as these large 4-kilometer model output. So it's a huge challenge to wrangle and manage all those different data sets, but that's what this is. That was our purpose, was to try to simplify and do all that in the back end so people could just compare things and look at them. And so we tried to separate this back end from the front end, and the front end are the interfaces, the client in the lower right, number 3, where you have people can look at this information on their phones or in websites, or they can use our API to stream it into their own applications. So here's some of the basic features. It's your basic web mapping functions, backgrounds, our API, animation. That's actually not typical. Animation is usually not part of web GIS type systems, but that's coming from a group of meteorologists, that was an essential required feature. So we put that became front and center of this project. The ability to embed your map in a website, and that's what we're doing in this project for GeoAquaWatch. It's interoperable. Let's see, some more advanced. Let's see, we can do the automated uploads. Other people can push their data to us. You can set thresholds for particular products that will then send out a notification. I have one that every time it starts to rain to the west of me by about 100 miles, I get a notice on my phone, because it's usually moving from west to east. And I'm a bicycle commuter, so that's important information at the end of the day. But you can set it for anything. It could be like, is there a fire near my cabin or something like that. Collaboration screen mode, we don't use that very often. Let's see. And then the possibility of other people acquiring one of our VMs, if we have partners to work with, we'll let them have a VM and they can spin it up, and they can choose whether to connect their instance with our federation or not. So let me just show it to you now. I think I'm gonna stop sharing this window and go to a different thing here. I'll just show you what RealEarth looks like. So this is the basic Slippy map, pan and zoom. This is what it looks like with no data in it. And then we have all of our data sets over here on the left that can be brought in. You can also search for a particular one if you're looking for something in particular. I'll just grab surface smoke, for example. So this is, it's not a whole lot of fire going on right now, but this is the HER smoke model output as it looks for a couple days from now on the 27th of January. And that's just, and we can animate that with these controls up here. So there's something going on in Texas that appears to be a fire that's probably likely to be producing smoke in the next few days, which is what we're seeing here. And so this is, you know, current. Let's see, another, I think now I'll just go into, so the part of the issue here is that we have like this huge number of products. These are just the smoke products, but you know, if you see in this, like what we call the RealEarth collection, we have different collections of data. We have, you know, we literally have thousands of products. We have over 1,000 products in here. These are just fire detections. Here's some flood data. But we also, and so part of the challenge now that it's become so full of information is how do you find what you're looking for and how do you customize it so that you aren't distracted by all these other possible things to look at. And so we came up with the notion of these are categories here on the left that we, and then we also have larger container for those called collections. And so we have a collection that we've created called Global Water Quality for this project, and we put in our AquaWatch data sets in here. And these are the ones that we're going to be looking at that are embedded in the AquaWatch website. So let's go there now. I'm going to switch to that tab, which should show up about now. And so this is the development site for GeoAquaWatch, and we've got a web page in here now that embeds the RealEarth maps. Just four sets of maps so far. And what we've done here is we've got this, we're essentially using an iframe to populate a RealEarth instance that has this, got all the functions that we just looked at, but we've pre-populated the map with the products that would be of interest to global water quality in the GeoAquaWatch context. And so working with Steve, we identified some collections of data that we thought would be useful to be able to pull in and look at in either near real time or the most recent available data, or collections that are maybe comparable but different from different sources, and to have a common interface to look at them in. So this first one here is the, you're probably familiar with it, is the multi-sensor gap-filled NOAA product. It's pretty remarkable. It's made with VIIRS, both SUMI NPP and NOAA 20, plus the OLCI and Sentinel-3A, and so you end up with a really nice data set here that's really smooth, but you know, it's pretty, you have to know where it is to find and so we've done that work of going and getting it and putting it in here into RealEarth so that we can look at it and look at the different set, the three, we made a decision to do chlorophyll A, and I always forget what SPM is, but if you click on the eye, you can look it up here and see that it's suspended particulate matter. So we have information, we have a link back to the source of the data here, and we put in a legend, so it's something you can turn those on and off down at the bottom here. So, and then you can animate it, because we do animation here, and that produces some interesting results when you're looking at things like, daily chlorophyll in this gap-filled mode, you start to see, since we got all 3 layers loaded here, let me turn off the other 2, but okay. So you can see sometimes, like if you, let me go into, I was noticing earlier some interesting activity in the Mississippi River and the Gulf with chlorophyll. I think it shows up more if we go to maybe 20 days time steps and apply that. Pause it for a second while it loads. Zoom out a little. This might look better with this one. Let's see. All right, so this is loading all of those time steps, and you can see up here in the clicker, at the top of the screen, we have the date and time of the observation. This one's still loading, so it's flashing until it's done. There we go. Yeah, that one's not quite as interesting as I was hoping, but we are in January, so maybe if we looked at a different date, we would see something more. But the point is, you can start asking. This prompts questions. When you look at what's going on here, you might see some pattern that then you can follow up on later or overlay. Because you're in the RealEarth interface here, you can add something else to it. Some other data set that might, like maybe you want to see where the lightning was happening, or where some other data set that might be relevant to what you're looking at here. So that's just this one. I added a link that allows you to view it, to pop it out into another tab if you want a bigger map to work with. Scrolling down, we're looking now at the Copernicus Global Land Service data sets. These are the first ones we added, and we added just surface temperature and trophic state and turbidity. Those are kind of the 3 big ones, and these are updated. Let me look and see. I don't have time. I don't have. Maybe it's this one. Yeah, every first, 11th, and 21st day of each month. So it's kind of an unusual 10-day collection period, but the last. Sometimes it's 11, or it just depends on the month, but 1st, 11th, and 21st. And so you get these, and here again it's a Sentinel-3 derived product, but really kind of interesting and useful. This comes from the Brockman in the Plymouth Marine Lab. So, and these are, I just happened to set it to zoom in on the Caspian Sea, which you can turn on labels if you want to get some information about what you're looking at here, but where you are. And you can change the background map. As I mentioned before, it's set to satellite right now, but you could change it to just like a OpenStreetMap or something. Yeah, so that's another collection of interest. And you have a little description of what the collection is about and where it comes from. And then down here we have the ocean color daily satellite observations, and this one's kind of interesting as a daily product. You can really see the detailed temporal detail and change. So you can get smoother animations if you're interested in that. Let me run one here, see if we can pre-cache. Some of these have not been pre-cached, so we're doing this with data that hasn't been looked at yet. It's relatively fresh. This collection goes annually. We harvest a whole collection, so this is the 2021 collection, which is the most recent one we have access to. but I'm expecting 2022 will come out pretty soon. But you can see this is we're getting polar orbiting satellites here, so that's why we're seeing kind of the shifting and gapping. But let's see. And then we also have added the CETA. These are more like inland lakes. So we have some of these that are, the oceans, and then others we're looking at the inland lakes. This is the chlorophyll A layer of which I have it, I think I default to July just because it's more interesting at that time of year to look at chlorophyll. Oops, I'm going to go in. Here we go. Some of the lakes in Minnesota here. And let's see. So this is like all satellite derived and satellite data. Some of it's combined products, some of it is individual observations. But we also have been looking at the GEMS in situ data. And so we added a portal for looking at that. And that's what I'm loading up here. And so essentially the GEMS database is we harvested the 2016 through 2020 so that it would coincide with the satellite imagery that we have. But it's such a sprawling database of, because it's a aggregation of different countries uploading their information, it's very irregular and heterogeneous. You get, sometimes you get very intense monitoring of a particular type of water quality, and other times you'll get sort of more survey level, just one parameter. And so it's a challenge to how do you visualize that, how do you find it? And there is a whole GEMS map and interface that is really useful, and but it only lets you look at GEMS data. And so the idea here is like, well, let's see if we can pull that out and then make it something that we can overlay with our satellite imagery. And in this case here, the idea is to be able to identify what you want to look at. So let's say we have this range of data, and let's be more specific about let's go to, just look at January through September. And then we'll say we want to look at something like total organic carbon. It'll tell us here, it autofills like what are the possible ranges here. So it says 0 to 2,000. So let's just say 1,000. And then let's filter, and it will say we're looking for this. Let's see, we're not finding any for these dates. So let me try chlorophyll. It's more likely. Let's put in let's say greater than 0. So anything. Let's get rid of this filter. And now it's saying we have 162 dates within our range that we can pick from. So let's get something in the summer, Northern Hemisphere summer. And here we go. Now we have a bunch of chlorophyll measurements for July 20th, 2020. And if you click on them, we'll tell you what the database says. So it's a way of filtering and sorting. It is a global data set. This looks like this is one of the US contributions, so we're not going to see it anywhere else. But if we picked a different date, it might be in a different location. So you can also, we have this pan to the data so you can find it. So this is kind of like, okay, why is this useful? Well, now we know that July 20th has some chlorophyll data over the US, and so then we can go back to our other page here, and ideally we're going to add some ways to add satellite imagery to this map. We haven't done that yet, but if we were going to go here, for example, and we want to look at this gap-filled chlorophyll A, let's turn on chlorophyll, and let's see if we have a date that matches here. If I click on this little clock here, it'll tell us all of the times that are available. This isn't the most elegant interface to get your dates, but we know, let's see, I think it was July 20th. Here we go. So now we're adding that. So this is the same date. And then we can go to our products here, and let's say we want to limit it to the water quality products. We scroll down, and here's our GEMS water quality. We pull that over, and there they are. So now we have our in situ measurements to go with our satellite imagery, and that's kind of cool. You can go down here and see what this says. And we've got dissolved organic carbon. In this case, we're not filtering by attributes, so it's going to show us everything that it measured for this day in that area, and it'll tell us where it was collected. And it comes with a station ID. So if you, oops, sorry. If you hover over it, it'll show you the station ID number. This one's USA 00525. It might be a stream gauge or something. So that's this is unique. I don't think there's anywhere else where you can grab the GEMS data set and overlay it with a specific satellite product like this. And so in this case, like we could even look at a different product underneath it and say, what does that look like, and what does this look like if we look at the KD490, for example. So it's still, we'd like to make it a little easier. Like I had to jump through some hoops to find coincident dates and products, which we just did. I hadn't rehearsed that, so I didn't know if I was going to find anything or not. But by knowing that we have a collection that goes from 2020 to 2016 through at least 2020, and this one goes to 2023, I felt confident that if I grabbed a GEMS value for any day, I would be able to find it in this gap-filled product. So I think this is an amazing product. It has a difficult name, so the data interpolating empirical orthogonal function, or DIN of is fantastic, but it's hard to say. Let's see. So what else do I want to show you here? I think the other there's a few more things about RealEarth that I can show you. One of the issues, one thing I'll mention is if you're not we're working on a way to make sure that the imagery itself does not start to show volume usage watermarks, which some of you, if you're following along, might be experiencing, because it will be going to because RealEarth has a volume limit on free usage, and I'll show you why that is. Part of it is we have a really here's our live stats showing what RealEarth is doing right now. And we have a lot of users. And we don't want to be a victim of our own success and have our servers brought to their knees all the time by usage. And we're exploring ways to deploy parts of this to the cloud. But since it's near real time, the constant updating of data makes that a real challenge. We can't just, sometimes caching and staging takes longer than the next data, especially for the 1 minute data. It's really hard to keep the cloud synchronized with all, if it's going to be distributed all over the place, if it's changing every minute. So that's one of our issues. The other is cost. There's egress fees and things like that when you get into staging on Amazon Web Services or other Google Cloud or others. So it's not quite as simple as just put it in the cloud. There's some issues there. But we are containerizing in some cases some of the elements that would allow it to be docked in the cloud and distributed more easily. So we're exploring that. But what you're seeing here is real-time usage. This is what's happening right now, and it's just showing on the left you have what we call kind of our leaderboard of the most popular products, and then on the right we're seeing what's being looked at. Not who's looking at it, but what is being looked at. And then we have some statistics on, we have, as I mentioned before, we have over 1,000 products, which is what this says here. That's just reading our database. And this, we have this many users, unique IP addresses served, which is 1.14 million IP addresses. There's a lot of computers. And then we have total hits. This is each one of these little squares is a hit. So that 8.42 billion. It's a really big number, but it doesn't necessarily mean that much. It's just the volume. It's just basically the workload of our servers over time have been serving that much information. But a hit is a small hit. It's not a big thing. And then this is just like right now in the last 33 minutes. This has been running since the webinar started. So we've accumulated this many hits, 64,000 and counting. And this list goes on. I think I don't know how many we show here, but it's maybe our top 50 or something. No, it says 81 on the left. So it's 81. This will keep growing, I think. So in the last 34 minutes, 81 different products have been looked at. And some of these will be the ones that we were looking at. So let's see. They should show up in here. Here's the Ceta chlorophyll A we were just looking at. That was probably us. There should be some of the others, but at any rate, this is kind of what's going on. So the point of this is that there's a lot going on, and we can't just perpetually give it all away for free. And so we have a watermarking system that by volume will, and by there's three categories. If you want to get GIS output, or you want to get huge graphics, or you want to get look at it a lot, any of those three things, it'll be watermarked. And but if you're a partner of us, if you work for NOAA, if you have any affiliation with us, then you're entitled to get it without watermarks. And also, when we embed it in websites like GeoAquaWatch, we don't want any users to have to experience watermarks there, because they're actually using GeoAquaWatch and us through that. So we are in the we've got some methods with keys and authentication. You can create a login if you're just using it personally at home. That will give you access with less watermarks, and you can also talk to us and we'll provision it, you know, to be limitless. We're not trying to make it inconvenient. We're just trying to put up a bit of a paywall for commercial users, and we have about half a dozen commercial users that, and we bring in about $50,000 a year with their subscriptions, and that helps us buy servers to keep our you know, every 5 years or so we have to replace a server, so we have a kind of a cycle of servers going through. We just replaced our head nodes, which are, and it's difficult to charge project money to something that's kind of universal like that. The projects that pay for specific products or activities create enhancements that then everyone gets to share, but some of the basic infrastructure stuff, we have to find other ways to pay for that. And part of that is the proceeds from companies that are willing to pay to have access for their own clients. So it was a lot about metrics and all, but let me go to our home page where you can find out more about RealEarth itself without being an advertisement for RealEarth. This is just kind of about our program. Here's where the watermarks are explained, the pricing model and all that, and what they look like if you start to get watermarked. We also have some info about how the API works, and we have documentation for the API. And then we've been more recently adding how-to videos here, quick guides and that sort of thing. So let's see. Going back to I'm going to share another tab here. This is if you want to see the entire collection, we have a product inventory page that's just /products, and these are all those collections we looked at before. So like here's the global water quality one with 11 products in 3 categories. Some of these need to be updated, so we have like other. This one hasn't been assigned to it should be up here, but you know, and we had some residual Great Lakes products that we folded in. They're not global, but they're regional. But if you looked at the whole, you'll see this is where we have the full, you know, 1,183 products in 134 categories. This is why we need to embed and create subsets that are easier for people to navigate and find, and because I mean this is pretty bewildering. Before this was just a text list, so it's actually gotten better. So let me just go back to the default one is called the RealEarth collection, which is a little bit more manageable. It's about half as many products, and these are, you know, all over the place. There's a little thumbnail that populates with what data are actually available at the moment, but it's a global map, so something like Gina snowmelt is Alaska only, so you get little bits on the east and west. But if you click on it, then it will show you what dates are available, and if you click on a date, it'll show you what times are available. You click on a time, it'll show you where it is, and you can get some metadata in JSON format, or you can display it in RealEarth, or you can get the interoperability things here, the WMS, WMTS. But if you click on display in RealEarth, then it will open a new tab like this, and here's the data. I'm going to turn labels off here. So this is Gina's snowmelt. It's not particularly useful right now. It's a cloud cover, but so Gina is the Geospatial Institute in Alaska, but at University of Alaska. Let's see. I think I'll go back to here and I think I can open it up for questions. This is essentially, work in progress. It's I can see the number of product groups growing as other data become available, and I hope it helps illustrate what's possible, and I hope it's useful. And with that, I think I will. I could stop sharing, I suppose, or open it up for questions.
Thanks, Sam. Really appreciate it. It's a great talk. And maybe you want to leave your page up there in case there's some specific questions leading to it. I would just add to the end there that now folks can see which data sets we have put in there, such as the NOAA data and the Copernicus Global Land Service products, the CCI stuff. So, and this was my choice. I mean, these are just data sets that I chose to put in here to start with. And I would really like to hear from the community of if they have other data products that they think that are relevant, that have this kind of global coverage for the most part, to please, you can type it in the chat here or get a hold of me. And though the project is done, we and I say we, this is Sam, could maybe add it to this collection here. But again, this was a community effort, so I want to get some feedback on this and get your thoughts about other additional data which would be relevant to your work. And with that, again, if you want to type anything in the chat, questions there, or just unmute yourself and go ahead and chat with Sam. This is fairly informal here.
It's Mary Beth. I just wanted to, I don't really have a question. I just wanted to say that I could see a lot of value in that, the personalized notification that you put out or that you mentioned that notifies you about when there's rain a little bit away from a target location, because I think that would be very valuable, perhaps for people who want to tag their nearest lake or their nearest beach, or a lot of aquaculture folks want to know if a harmful algal bloom maybe is coming their way, or in the future if sort of turbidity events or dissolved oxygen can be forecast as well. That might, I think, be useful.
Yeah, thanks for mentioning that. I just pulled up the, let me share this tab. This is the interface for where a user can set their notifications. I have one for floodwater, for fog, for rain. West of Madison is the one I described, and then Western fires too, just because I'm on a fire project and I want to know kind of what's going on out there. So, and essentially what you do is you set a boundary for the area of interest, and then you assign the products that you're, like the product I'm interested in is called Current Large Fires, in the collection of fire detection. And so,
does that come to you on your phone, or where does it
yes,
come to on your
yeah, it's a
okay.
text message.
Good.
And then it has
Yeah.
a link back to the product so you can look at it.
Because that's exactly what users want. There's a lot of users who, they're out in the field, they're out fishing, they're out, on the lake or doing whatever, and they aren't near a computer, so they can't see like where's the bloom today, but they want to know if something's coming
Yeah,
for
that's
whatever reason.
exactly, yep, that's exactly. It's not as fully developed. I mean, we use it internally because we know how. It's not super easy to figure out, so we haven't written documentation for it, which always lags behind. We're typical university, you know, we have all these great ideas and we do these cool examples, and then people say, "How do I do it?" And we're just like, "Well, it's complicated," you know. So not particularly helpful, but we're working on that, and we do know notifications are important. And especially for we have a project now that's with NOAA that involves fire detection, and um, some of the folks on the ground would like to, who are managing or fighting the fire, the IMETs, for example, the incident meteorologists are concerned about lightning for the people that are fighting the fire, and their part of their job is to warn about things like that. And so we have a lightning product that uh, uses AI to predict where lightning might, you know, probabilities are increasing, and it will we can create a notification for that, so that when it reaches a certain threshold, like over 80% or something, or 70% or whatever, it will notify with, you know. So there's a lot of possibilities there. It's a little, you know, we're not. There's a liability issue there too, where if you start, we have to fill our stuff with disclaimers, because we're not really, you know, we're not authorized to be doing emergency management in that way. So we have to be cautious about how this is used, but for more casual use, it can be really valuable.
Any other questions for Sam?
This is Emily. I have a question. When you say the project is finished, I guess what do you mean by that, and what future opportunities would there be?
Yeah, good question. So the project, we had an internal grant at Space Science and Engineering. I'm going to switch back to this tab. And it was part of our developing strategic partnerships and improving technical capacity. And so this project really pushed us to do a better job of embedding maps and things like that. So the kind of the basic, the funding that Steve and I got in order to collaborate on this and identify the products and put them in, and, you know, and wrangle the data and figure out the GEMS thing was a big part, complicated effort. That part is done. The kind of like capability growth. What we still have though is we have enough sort of income through the same money that we use to buy servers and that we get commercially is unrestricted funding, and we can, if somebody comes to us with a particular product they want to add to our system, we can use that. We can apply, you know, pay for hours of time. We basically are an hourly billable, you know, unit. So as long as we have, you know, if we have enough time, we have some money to, and if the effort's not too great, then you know, like between, I'd say 4 and 16 hours, we'll do it, you know, and then usually that's pretty straightforward for adding data sets. If they're already in like a GeoJSON or GeoTIFF format, we can use it right away. If it's NetCDF, usually we can do it, and if it's HDF5 also, but some of that depends on how sort of like geospatially ready the data are. As you know, some you know, NetCDF is there's so many ways it can be formatted that it doesn't always work for us to. But we've got some techniques to figure that out, and working with the meteorology community, we get a lot of data that was never intended to be put in a GIS map. So that's one of the things we're good at, and a lot of that is work we've already done. So it's not, it's methods we have in place. So yeah, so I guess the answer is if it's a special product that has value and seems worthwhile, a lot of fuzziness there, but we'll do it. We'll put it in RealEarth, and that's how we've ended up with 1,000 products. Is a lot of people have come to us with saying, hey, it would be really cool if you could put this particular estimated rainfall in, or this whatever, and we put it in. So
Okay, great, thank you.
Oh, I did want to ask, Sam, it's Mary Beth again. Did you have a date when you expect this to go live on the GeoAquaWatch website? Maybe like a target?
I think, I think it's pretty close. I mean, I don't know, it's
Okay.
sort of up to Steve, I think, and really, I feel like it's pretty much ready for at least this page,
Right. No, I think we could, and I don't know what it takes to flip that switch, but I think, again, particularly now with doing this webinar and we've gotten a little more visibility, it would be a good time, and maybe we can talk about this offline, Mary Beth, too, but maybe on the front page at least make a note of that, or an announcement, and point to it for people.
Oh, just while we were talking, I forgot to show this feature. We have this for some of the data sets where we have a history, which for all of them, I guess we do. If you right click and do the probe, you get a option to add. It'll give you the current value of that pixel, but you can also show the time series for that pixel, which is kind of useful. And it's based on the number of dates that you have selected over here on the left. I don't really have access to the chat while I'm presenting that I can see, so I don't know if there's anything in the chat. Let me know.
Yes, we are moderating the chat for you.
Oh, great.
I just wanted to point out to everybody, just in case you came late or you haven't seen it, that we are recording today's webinar. It will be posted at the link that I just put in the chat a little later today. It takes about an hour or so for it to process, and then maybe another couple hours or even a half a day for me to get it up on the website for you. And then our next webinar will be presented on February 2nd. We've had quite a lot of webinars in a very short time period, which is uncharacteristic for us. So we hope that you'll hang in there. We'll have a little bit of a breather after this next one, February 2nd, presented by Petra Philipson and Victor Martinez Vicente. It will be entitled Biomondo by Comb and Booms, about a project on Swedish lakes, I believe. And I put the link where you can find out more, read the abstract and speaker bios also in the chat.
Okay, thanks for that, Mary Beth. Any last questions for Sam before we close this session? I do appreciate everybody coming today, and it's good to see some familiar names on the list there of participants, and I'm glad you could join us today. If not, I think we'll go ahead and close this webinar. Sam, again, we appreciate you taking time to come and talk about RealEarth with us. Like I say, I think this is great stuff, and it's a great product, and I think it's going to get a lot of use when we get it up and running on the AquaWatch website.
Great. Well, I really appreciate the opportunity to present today, and I will stop sharing now.
Okay. Take care, everyone, and enjoy the rest of your day, and we'll see you at the next webinar.
Thank you.